Hello everyone, in this video we're going to talk about properties of radicals. So it says let x and y be real numbers such that the indicated roots are real numbers, and let n be an integer greater than 1. And we have two properties that we're going to focus on today. We have the product property and we have the quotient property. So for the product property, we see we have two numbers being multiplied together. That was represented by x and y, and we are taking the nth root of that product. And so what this product property tells us we can do is essentially separate that multiplication. Or if we already have two roots of the same root, two square roots being multiplied together, we can multiply the radicand, the number that's under the root, and then we can take the nth root of that product. Same thing with quotient. If we have two terms being divided, then we can separate that division. Basically, a square root of a quotient is the same as a quotient of square roots, right? Or if we plug in whatever root we wanted for that. And then also if they are already separated, then we can take whatever the radicands are, x and y in this case, divide them, and then take that nth root. So we're going to look at four examples, 2 for product and 2 for quotient. So for example number 1, we see the cube root of 4 times the cube root of 128. Well, if we notice 4 and 128, neither one of those are what we would consider perfect cubes, so we can't take the cube root of those right away. But we could rewrite this as the cube root of 4 times 128. And so if we do that, 128 times 4, that gives us 512. And now we do know that 512 is a perfect cube. The cube root of 512 is 8. So number 1 is equal to 8. Number 2, we're going to go down here to the bottom. We have a quotient. So the fifth root of 192 divided by the fifth root of 6. And we could write this as the fifth root of 192 divided by 6. And so in our calculator, we could do 192 divided by 6, and we get 32. So this is equal to the fifth root of 32, which is equal to 2. Okay. All right, and number 3, back to the top here, we have a product. So the fourth root of 27 times the fourth root of 3. Well, we could write that as the fourth root of 27 times 3, and we get the fourth root of 81. So the fourth root of 81, we said, would be 3. And now, since this is an even root that we're taking, the fourth root, we should write this as positive or negative 3. All right, number 4. We have the cube root of 250 divided by the cube root of 2. And so we could do 250 divided by 2. We know that to be 125. And the cube root of 125 would be 5. Okay? And so that's a little bit about the product rule for radicals and the quotient rule for radicals.